Good afternoon and welcome back. So today we're doing the last lesson for radio technology. So we're doing part 3 of 3 today. And we'll be continuing with what we spoke about in the previous class. So the previous class, we finished up with how everything gets put together from a technical point of view, so all the hardware. Today, what we're going to be doing is we're going to be looking at it a little bit more in depth. So you might remember some of this if you had science at school, because we'll be talking about the amplitudes versus the frequencies in detail. So what you should be able to do at the end of this lesson is you should be able to identify and elaborate on transmission distribution technology, and you should be able to explain studio fault logs, house style guides, and procedures associated with maintenance and studio security, as that will be our last focus. So before we go any further into this lesson, I want you all to go to page 285 of Next Level Radio. So at the bottom there, you'll see there's an activity 7C. Okay, so it's important for me that you should be able to understand, you should be able to answer all of these. So what is DAB, topography, FM, digital dividend, internet speed, ISP? Okay, and then number 2 there, discuss the advantages of traditional radio station creating podcasts. Does that sound familiar from the previous class? It should. And then thirdly, as a technical producer at XFM, you must prepare for an outside broadcast taking place at a political press conference. XFM's program manager wants to broadcast during the press conference and conduct interviews with the key politicians after the press conference. The 9 to 12 show consists of a presenter, a news and traffic reader, a sport presenter, and one producer who also participates on the show as a contributor. Create an equipment checklist for the OB. Again, this should sound familiar from the previous lecture. And then if you go to page 286, there's your equipment checklist. So all you have to do is just fill in which items are required and the number that is required, okay? But with regards to activity 7C1, a couple of the things that we will be chatting about today, some of these words you might not have heard before, so we'll be discussing them in detail. That being said, let's go to the PowerPoint. So we're looking at page 280 to 286, so not a lot of reading. Okay, distribution technology. So amplitude versus frequency. I'm not sure whether you've heard this before. Again, if you had science, you might have. So the amplitude and the frequency of a wave, if we have a wave, is equal, okay? So the difference between frequency and amplitude is that frequency is a measurement of cycles per second, and amplitude is a measure of how large a wave is. So amplitude represents a wave's energy. For example, a sound wave with a high amplitude is perceived as loud. And frequency is just the number of waves per cycle passing a point per unit time. You don't need to know this in detail. It's just to give you some background about the difference between the two. So AM sound waves can travel extensively across the surface of the Earth and are carried by the Earth and the atmosphere. But they are, however, very noisy. Okay, so if you believe like me that the Earth is round, then an AM sound wave can literally travel across the platform of the Earth all the way, okay? So it can extend a lot further than FM signals can because it can bend. So AM signals can bend. The reason that these AM signals are so noisy is because they can be greatly affected by atmospheric conditions such as rain, clouds, or lightning. FM signal, on the other hand, is much clearer and less affected by atmospheric conditions as the waves travel in a straight line. Again, think of my Earth that I spoke about. So imagine that I now have an FM signal. Obviously, the Earth is round, not straight, which means that an FM signal can only travel a small distance before it needs to be able to curve, which it can't. So this means that they will travel until the curvature of the Earth prevents them from traveling further beyond the horizon. So again, wave size is amplitude, wave repetition is frequency. So how many times in a specific time frame the wave repeats itself. So here you can kind of see what it looks like. So there's the signal, there's the AM that can bend, and then the bottom one is the FM one that can't bend, it just goes straight. So AM, very noisy, FM, much clearer. So for people to hear sounds, there needs to be a force that starts the waves traveling. So they need to get started somehow. In radio, that force is called the transmitter. So how it works is the transmitter uses an electrical power output measured in watts to send audio waves out so that they can be picked up by people's radio sets, which then decodes the waves into sound that we hear. The footprint of a radio station, so how far and to what a station can send out its waves, is determined by the number of transmitters that it has, as well as by the power output capability of those transmitters. If a radio station has more transmitters, it can cover more ground. If those transmitters are higher powered, then it can also reach further. So our transmitter's height plays a role in how far the waves can travel. So look at page 281 in your textbook. You'll see there's two examples. If a transmitter is 10 meters high, you can see how far the signal can stretch. Versus if a transmitter is 100 meters high, you'll see how much further it can go, okay? Think about South African radio stations. Which stations on FM are countrywide? These guys, especially if they're on FM, need to have a lot of radio transmitters because on FM, like we said, it's straight, okay? The FM waves are straight. So it needs to bounce from one transmitter to another, to another, to another, to continue carrying the sound over. Versus smaller radio stations that are perhaps regional, that might only have one transmitter that's 100 meters tall, situated on top of a very tall building. So they can then have quite a large radius simply by how high they are and then how far the wave stretches because of how high they are, because of the distance. See, very technological, very sciencey today. So here you go, you can see what they look like. So on the left, a signal radius of 1 kilometer. On the right, a signal radius of 10 kilometer because of the transmitter height. Left is 10 meters, right is 100 meters. The industry standard in broadcasting is to use FM broadcast. Why do you think that is? Why would we rather use FM broadcast if AM can stretch so much further? Obviously because the sound is so much clearer on FM, because there aren't all those noise interruptions from rain and clouds and lightning, etc. There are, however, still a few AM signal radio stations in South Africa. Can you think of any? Think of talk radio stations. There should be a few that can come up to mind. The reason that it's mostly talk radio stations is because the quality of the reception by the listener is less demanding on the single channel of talk. So when you talk, it's one layer versus if you create music, it's multi-layered, okay? There's a few layers like we use in music production, meaning that the sound that will be released sounds completely different. There is an exception. There's a radio station in Cape Town called Magic 808 AM. They've been going for a few years and they broadcast on AM frequency and they have quite a big footprint that they cover. But you'll see if you tune into them to try and listen to them, there's a very almost tinny, hollowy sound to the reception where we are used to extremely crisp, clear reception on the FM channels. So now we're going to look at stereophonic sound and how it's used. Stereophonic meaning, or more commonly simply known as stereo, is a method of sound reproduction that creates an illusion of multidirectional audible perspective. So what that means is you hear in both sides, okay? Not just on one side like mono. So you get mono versus stereo. If you record something in mono, it'll only be on one channel. If you record something in stereo, it'll be on 2 channels. The use of radio waves as a method for transferring sound has become quite complicated. Radio waves can only bend so much, as I just mentioned, which means that there's a limit on the spectrum of waves that can be used. Spectrum, think about that word. Have you heard that before? Radio stations have a spectrum license, which comes to their footprint in essence. As a result, there's a limitation on the number of radio stations that can use the available spectrum of airwaves. South Africa's airwave spectrum has become extremely cluttered. And if you look at the breakdown of how many radio stations there are in specific regions, Gauteng is so dense with radio stations. So one of ICASA's jobs, ICASA standing for the Independent Communications Authority of South Africa. One of their jobs is to manage and assign the airwave space to specific radio license holders so that they can broadcast using the FM signal. If you look at page 282 in your textbook, in the middle there, you'll see a table that illustrates the different frequency spectrum services that are available in South Africa. So you'll see it starts with very low frequency signal and it goes to extreme high frequency signal. So FM and communication is somewhere in the middle there, okay? You can start with FM signals from as little as 30 megahertz, but on average, you'll see there from 300 megahertz to 3000 megahertz. And you'll see the ones that are very low are things like the submarine communication. Extremely high is astronomy and weather prediction. Keeping in mind how densely populated the South African airwaves are currently, we're now going to look at digital audio broadcasting, better known as DAB. Due to the restrictions and limitations on expanding into the FM space, communications regulators are always looking at new ways to broadcast audio. Currently in South Africa, there's a trial that ICASA is running on a technology called DAB. What DAB does is it converts the broadcast signal, so it converts the waves into a digital signal, so ones and zeros in essence, which saves space on the limited frequency spectrum because it takes away these waves and it literally transfers it into ones and zeros into digital. So in this way, by going digital, space is freed up by using digital packets of data instead of the radio waves. So these digital packets of data, again, just think of ones and zeros, okay? This means that we can use the frequency for other priorities that better serve our country's infrastructure, such as the wireless broadband, which we all know we need, and we can introduce more radio stations for variety and competition, seeing as we're not utilizing that frequency space anymore, but we can utilize digital space. This is called the digital dividend, as using digital packets of data frees up space on the frequency spectrum, as we just mentioned. So you might be saying now, wow, this is amazing. Why don't we simply do it? Why don't we just implement it? There's a lot that goes into DAB. The DAB test has taken a number of South African radio stations and converted them into a DAB signal that can be picked up by a DAB receiver. This doesn't mean that these stations are now purely only on DAB. This is done in parallel to the stations maintaining their FM distribution so that listeners who do not have access to DAB will not have their listening interrupted or terminated. So I have a little Bluetooth speaker, a JBL speaker, that picks up DAB broadcasting, so DAB radio stations. And on there is, for instance, 702, 947, Metro FM. So there are a few big stations on this that they are testing out currently. But again, as we know, not everyone can afford one of these Bluetooth speakers, and not everyone has devices that they can listen to digital audio broadcasting on. So it's very important for them to run the two in parallel. So once the test is concluded, the Department of Communications, or how we know them now, is the Department of Communications and Digital Technologies. FYI, if you didn't know that, now you do. These guys will need to decide whether or not using DAB technology will serve its mandate to reach as many people across the country as possible and provide them with audio content for entertainment, information, and education. So that is in essence, at the end of the day, the aim with DAB is to get it to as many people across the country as possible. It will then need to consider a phased approach to ensure that all South Africans will not lose their access to the radio offering available. Again, because as I mentioned, everyone currently does not have access to these kind of technologies. So a DAB receiver looks like a modern radio set, but it has an interactive LCD screen. So you know those little screens that project things on them, where further information is given about the station. For instance, firstly, what is the station? What is the show that's on air currently? What is the song being played? And news stories being delivered that can be found. What this means for us as South Africans is that they would need to replace their current radio sets with a DAB receiver, which is much more expensive than a radio set, unfortunately. On the upside, though, there's a lot less interference, making a DAB receiver a lot more reliable than your typical radio set. There is an added concern about the rollout of DAB within South Africa, and that is the distribution of the South African population. In densely populated areas, DAB works very well as it uses a series of smaller transmitters to share the binary data packets, so the digital data. And this way it works very similar to cellular technology. An FM transmitter uses one large transmitter or a series of large transmitters to cover a much wider footprint. Although FM does experience interference from weather and things like hills and mountains, as well as other topography and buildings in these kind of surroundings. A word there that I mentioned at the beginning, something that I mentioned that you should know by now, or that you should know at the end of this class. Topography. Topography is a detailed map of the surface features of land. So this includes, like I mentioned, the mountains, hills, creeks, other bumps and things on a particular piece of earth. So topography will represent a particular area in detail, including everything natural and man-made. A number of car companies have started installing DAB receivers in their cars rather than the typical FM frequency finders, as they want to provide consistent listening opportunities for drivers who are moving in and out of the frequency range as they drive. So that is what digital audio broadcasting is. So now we've looked at AM versus FM, so amplitude modulation versus frequency modulation. So AM frequencies that can move around the earth and can stretch very far, but is very loud because it's influenced by things, for instance, rain, the clouds, lightning, etc. And then FM, which is only straight, which can't bend, but is much clearer as it's not influenced by the same atmospheric conditions. Then we've looked at digital audio broadcasting now, which takes these waves and then converts them into digital packets. So meaning we're opening up some airwaves because we're taking them away as we're converting them to digital for us to listen to. So we can use those spaces for other things, like for instance, wireless broadband. The next one now, satellite broadcasting. Our last consideration in terms of signal distribution and the distribution of technology is satellite broadcasting. Satellite technology receives an audio signal in waves from the ground, and a satellite in space that orbits the Earth translates that signal into a digital data packet. So digital data packet, the same one we get with DAB. So again, satellite technology receives an audio signal in waves from the ground, and a satellite in space that orbits the Earth translates that signal, that wave signal, into a digital data packet. This data packet is then sent back to Earth, where satellite decoders can translate the signal into an audio experience, into audio that we can hear. So this technology, as you can imagine, eliminates a lot of the geographical limitations that we had on both AM and we just mentioned about DAB. So this technology eliminates a lot of that geographical limitations that we spoke about earlier, as any household with an active satellite decoder can receive and listen to the audio product. Where have you heard the word decoder before? We currently have satellite TV within South Africa, so MultiChoice uses satellites. Negotiations between radio station businesses like SABC and Prime Media Broadcasting, for instance, in South Africa, with satellite broadcasters like MultiChoice, have enabled millions of South Africans to obtain access to a wide range of radio stations that they wouldn't be able to pick up via their usual radio sets, as they may live outside of that FM distribution footprint of that radio station. So if we go on to DSTV, there are numerous radio station channels on there. Okay, these didn't just appear there. There were meetings between, like we mentioned, someone like Prime Media and SABC with MultiChoice as to how they can get these onto their platforms, making use of their satellite decoder that's already in place. And that's why we can find it today. There are, however, downsides to something like satellite broadcasting. And some of these include adverse weather conditions between the ground and the satellite that is orbiting outside of the Earth's atmosphere can reduce the line of sight that is needed between a satellite in space and the satellite decoder on the Earth. I'm not sure if you've ever watched TV, so watch DSTV, and it just went off, especially when there's thunder and lightning and heavy rains. That means that the line of sight that is needed has been reduced between the satellite in space and the satellite decoder on the Earth. Another disadvantage is a satellite decoder must remain plugged into an electrical supply to be able to function. We all know this. If you unplug your decoder, no DSTV. This limits the portability of a satellite decoder, which is one of the key benefits of listening to radio. It's not like I can unplug it and take it with me wherever I go, so I can listen to satellite radio. Being able to take the sound with you as you move through the house or through your business is a key behavioral advantage for radio listeners. Okay, so that's satellite broadcasting in a nutshell. So we're seeing the audio signal in waves from the ground to the satellite, where the satellite translates it into digital data packet, which then is sent back to Earth, where the satellite decoder can translate this signal into an audio experience where we hear it. It is limited as it needs to be plugged in, and weather conditions can affect it. That was the last of the signal distribution technology. So that should give you quite a broad range about all the different ways that we can actually listen to radio. This might not sound very important, but from a radio perspective, for a radio station, these are extremely important. Maintenance and security are both very important factors to take into consideration.
Almost all radio stations contain a permanent fault logbook, where any faults that is discovered by the on-air and producer teams can be logged with a date and a time for the studio engineer to attend to. Faults can range from physical or hardware faults, such as loose knobs, squeaky doors, or broken chairs, to software faults, where one of the computer programs on the studio computer is causing difficulties for the on-air team. A studio engineer will check the logbook daily and attend to the faults that have been logged to ensure that the studio is running optimally at all times. In order for ongoing maintenance to take place, radio stations implement their own internal policies to safeguard their equipment. The technical producers or Studio engineers are responsible for developing these policies and for enforcing them according to the standards that are set. As you can imagine, this is quite important. Studio maintenance policies may include things like no eating or drinking in the studio. And for instance, if you do want to eat, you need to go to a green room or the green room. Another example is no chewing gum or popcorn is allowed in the studio or the green room at all. These two policies are ones that you actually get in a lot of radio stations. So all of the stations where I worked had this policy, no eating or drinking in the studio. If you did want to drink in the studio where I worked, you could do it out of something similar to a pump bottle, but that was it. And that was to the extremes. Chewing gum and popcorn wasn't allowed at all. Chewing gum because you can put it places, popcorn because the kernels can go all over the place. When it comes to security, radio stations tend to be quite strict. And most studios are protected by doors that are fireproof and soundproof, and has systems that require fingerprint scanning or access cards in order to grant access. So you can hear it's quite a strict. There's quite a strict process that goes on. Not just anyone can get into these studios. It's not a case of anyone can just walk in and walk into a studio and be like, hey, to the on-air presenter, I'm your biggest fan, you know, here I am. That doesn't happen. This means that if there's any guest that needs to be live in studio, a producer or a show team member needs to sign them in to allow them access. So most of these studios also have CCTV and cameras to ensure this process is followed and to ensure that anyone who is not adhering to the studio policy rules is held accountable for any damage or theft that may ensue. Over and above this, most broadcast businesses have strict security protocol when gaining access to the building before they even reach the studio. This consists of things like turnstiles, bag scanning sensors, metal detectors, and the requirement of showing your ID, as well as signing in any equipment that you have in and out of the building. I'm not sure if you've ever been to the SABC building in Auckland Park, but they literally have everything I just mentioned. If I went in there with a laptop, my laptop would be taken out, I'd get a number on it, and then I can go in, so it's been signed in. When I come back, I had to take my laptop out again, and then they would take back the sign that I got, and then it was signed out again. So it's a whole big process, and you wait at the bottom for someone to come down from one of the floors and come and fetch you before you can go back up. So you can't get past the security. So there's security at the entrance, and then there's security where you wait before you're allowed to go into any of the lifts. In terms of information and the use of software, there are additional policies that are typically put into place to safeguard content, like music and show bites, which are the property of that specific radio station and cannot, under any circumstances, be shared outside of the radio station unless authorized and credited accordingly. Wi-Fi passwords are protected and required logins, which means that security can literally track you and track what it is that you download and what you've watched. Similar to telephone calls. Normally you get a code and then they can also track that to see what you've called. And screen time might be limited to certain workstations in order to manage costs. So there's all these little extra things involved from a management point of view to make sure that the security is up to date and that it runs smoothly at all times. The station's most valuable assets are its studio equipment. These assets are managed accordingly on the station's financial statements and have to be amortized in terms of cost and tracked in terms of depreciation. This means that the station can spread the cost of new equipment over several years in order to calculate its return on investment once the costs have been paid off. This also means that you can project how long a piece of equipment will last, and then you can budget for when that piece of equipment needs to be replaced or upgraded. And that brings us to the end of this lesson. In this radio technology chapter that we just did, We looked at the two sides of radio technology, which was the equipment itself on the one side, and then on the other side, the radio professionals, the software and computer programs in broadcasting. We looked at the broadcasting chain. We looked at the playout systems, the newsroom technology. We learned about studio acoustics, which is very important. We looked at the mixing desks and the features. And then we went into detail on outside broadcasts and the equipment needed, and then available software with regards to broadband and radio signals. And then in this lecture, we identified transmission distribution technology and learned about studio fault logs, which we just spoke about, and procedures surrounding maintenance and security. So that is everything that you should be knowledgeable right about now. So please do me a favor and go and listen to a few radio pieces. I'd like to know from you which pieces stood out and why, because next we're going to start with content creation. And with that, I say goodbye until next time.